All right, let's talk about one of the biggest, most mind-bending rules in the entire universe, a universal speed limit. It's an idea that the brilliant physicist Richard Feynman really helped us understand, and trust me, it's a lot weirder than you probably think.
So let's just get right to it. It's the question we've all asked at some point, right? Why can't we just go faster than light? It seems like such a simple question, but the answer changes everything.
You know, the first thing you have to realize is that this isn't an engineering problem. We're not just waiting around for a better rocket engine. The barrier isn't something we can build our way through. It is literally woven into the fabric of space and time. It's a fundamental rule of the game.
Okay, to really get our heads around this, we have to start by pushing back against our own intuition. So let's start with what we can call the impossible push. I mean, think about it. In our day-to-day lives, things are pretty straightforward. You push a cart, it moves. You push it harder, it moves faster. Force equals mass times acceleration. It just makes sense. So why on earth does this perfectly logical rule just stop working when you get really, really fast? Well, that common sense rule breaks because it slams right into a much bigger, much more fundamental rule, and this is the first major clue in our mystery, the constant of light. You could call it the universe's most stubborn rule. This is where things get really, really strange. Back in the day, Albert Einstein figured out something that just shouldn't be true. The speed of light in a vacuum, we call it c, is always the same. It doesn't matter if you're standing still or zipping past in a spaceship. You will always measure light moving at the exact same speed. And that idea just shatters our common sense about how speed is supposed to work.
And this slide just perfectly sums up the problem. On the left, you've got our normal intuition. A truck's going 50, throws a ball forward at 20, you just add them up. 70, simple. But now look at how light works. A rocket is screaming along at 99% of light speed, and it turns on its headlights. You'd think that light beam would be going at 199% the speed of light, right? But nope, it's just c. The universe literally refuses to let you add your speed to the speed of light. Something else has to give. And what gives is where this gets truly mind-bending. It leads us to the consequences of that stubborn rule, what you can think of as the price of speed. You know that famous equation E equals mc squared? It's not just about atomic bombs. At its heart, it's a conversion rate. It tells us that energy and mass are two sides of the same coin. So when you pump energy into an object to make it go faster, not all of that energy becomes speed. As you get closer and closer to c, a bigger and bigger chunk of that energy starts turning into more mass. This chart just lays it out so clearly. At low speeds, almost all the energy you put in goes into making you faster, no problem. But look what happens when you're already flying along at 99% of light speed. Whoa. Now, a whopping 85% of any new energy you add just makes you heavier. You get barely any faster. It's like you're trying to run through cosmic mud that gets thicker and thicker the faster you go. And that's a battle you can never, ever win. To actually reach the speed of light, an object with mass would become infinitely massive. And to push something with infinite mass, well, you'd need an infinite amount of energy. The universe sets a price that is literally impossible to pay. But here's the thing. Infinite energy, that's just how the universe stops you. It's the mechanism. It's not the deep down why. And this is where Richard Feynman's thinking takes us to a much, much deeper level. He argued the real reason for the speed limit isn't about energy at all. It's about logic. It's about protecting cause and effect. So forget about needing infinite fuel for a second. The most profound reason you can't go faster than light is that if you could, the universe would simply stop making sense. The fundamental relationship between a cause and its effect would completely shatter. So how does that work? Okay, let's walk through this famous paradox. Step 1, imagine you could send a message faster than light. You send a text to yourself one day in the past. Because you broke the light barrier, that message effectively travels back in time. Step 2, your past self gets the message before you've even decided to send it. Step 3, acting on this impossible information, your past self does something that ensures you never send that message in the first place. And here it is. The whole system crashes. Step 4, the effect, receiving the message, happened, but its cause, sending the message, was erased from existence. It's a paradox. It's a logical impossibility. And this is the core of what Feynman was getting at. The universe has a universal speed limit, not just to be difficult, but because the only alternative is complete and utter nonsense.
A universe where effects can happen without causes is no universe at all. The speed limit is a requirement for a logical reality.
So let's put all the pieces together. This isn't just a limit on how fast a spaceship can go. This is the ultimate limit. This is the speed of reality itself.
This means we have to really redefine what c is. It's not just the speed of light. It's better to think of it as the speed of causality. It is the absolute maximum speed at which any cause can ripple across the universe to create an effect. It's the speed limit for information, for anything.
Here's a cool way to think about it. The speed of light is the pace at which the moment now becomes the future. It's like the refresh rate of the universe. To go faster than that would mean arriving in the future before it has even been created. And that leaves us with one final, absolutely tantalizing thought. If this speed limit, this speed of causality defines everything we know, what happens at the one place where our laws of physics totally collapse? The singularity at the heart of a black hole. What happens to the speed of reality when reality itself breaks down? Now, that is a question for another day.